Hello everyone, today we are going to do the full estimation of a building having a single room, and today we are going to consider the steps. We have the horizontal length of a room as 3.6 meter and the vertical length of the room is 4 meter. When we cut the plan from this cutting plane and we observe building from this side, then the section will look like this. Now let's visualize the 3D drawing of this question. According to the given plan, this is a ground level. These are the steps. Here is a door, but we can see that there is no any windows in this house. This is a RC slab, and above the RC slab there is a parapet wall, and here is a lintel above the door, and you can see that this is a plinth level and this is a ground level, and we can see that below the ground level there is a lime concrete all over the house. Similarly, these are the first footing of the building. In this plan, we can see that here is a steel grated door, and there is also a batten door in front of this steel grated door, and in actual practice it will look like this. That means there is a steel grated door and there is also a batten door in this building. Now let's assume that this is the AA section of this building, and when you cut this house from this AA section, it will look like this. We can see that this is the lime concrete all over the house. This is the first class brickwork in the footing, and here we can see that this is the brick soling of 10 centimeter. Similarly, this is the 10 centimeter LC, and this is the inner part of the room. You can see that there is a batten door and there is a steel grated door. This is the lintel. Similarly, this is the RC slab portion, and above the RC slab we can see that this is lime terracing and this is a parapet wall. This is the ground level. Below the ground level there is also the lime concrete of the steps. Today we are going to do this question by centerline method. So firstly we need to calculate the total centerline of this building, that is the summation of the horizontal length and summation of this vertical length. We have the center line of this building from this portion to this portion, and when we multiply this center line by its width, we will get this area. Similarly, we have the center line from this portion to this portion, and when we multiply by its breadth, we will get this area. Similarly, we have the center line of this wall from this portion to this portion, and we will get this area when we multiply by its breadth, and same case applies to this wall. But we can see that this small portion is considered twice when we calculate the area from this wall and this wall, but we can see that this small portion is not considered. So this small portion is easily replaced by this portion because it is considered twice, and if we multiply this area with the height, then we will get the required quantity. Now let's calculate the center line of this building. For this we have to calculate the center line from this point to this point, that is this inner to inner length of this room is 3.6 and this wall is 0.3 meter width. So we have to calculate this small portion, that is 0.3 by 2, and this small portion is also 0.3 by 2. So our horizontal length becomes 3.6 plus 2 into 0.3 by 2. And we have this portion twice, that is here also we will get the same length, so we can just multiply by 2. Similarly, we have the center line of this vertical wall from this point to this point. That means we have the vertical length of this room as 4 meter, and this small portion is 0.3 by 2, and this small portion is also 0.3 by 2. So we can say that this vertical length is 4 meter plus 2 times of 0.3 by 2, and we can say that this length is also same, so we can simply multiply by 2. So we will get the total length as 16.4. Now our first step is to calculate the earthwork in excavation in foundation. For this we need to see our section. We can see that we have to do the excavation of wall of 0.7 meter width. So we have to excavate this 0.7 meter wall up to the ground level. That means we have to excavate the trench of 0.7 meter width up to the ground level of 0.9 meter, like this. So we have the main walls number 1. We can easily write the length, that is 16.4, and we have the breadth as 0.7, and we have the height of the excavation up to the ground level, that is 0.9 meter. So we will get the total quantity 10.33, and the unit is cubic meter. Now we have to do the excavation of the steps. We have already excavated these portions of the wall. Now we have to do the excavation of the steps. That means this portion is to be excavated. But we can see here that this small portion is already excavated, so we don't need to consider this portion. From the plan, we can see that we have the value of these straits as 0.3 meter each. That is, this total length will become 0.3 plus 0.3 plus 0.3, that is 0.9 meter. If we subtract this small portion in this full length, we will get the required length from this portion to this portion. So we get this small portion as 0.7 minus 0.4 divided by 2. That means this portion is also 0.15 and this small portion is also 0.15 meter. Now we need to calculate this small portion length from this point to this point, that is 0.9 minus 0.15. So this small portion is 0.75 meter and this small portion is the width of the excavation and the length of the stair is 1.2, which is given in the plan, and the height of excavation is 10 centimeter, that is 0.1 meter. So we can easily write number of steps 1, our length is 1.2, our breadth is 0.75 meter, and our height of excavation is 0.1 meter. So we get the total quantity as 0.09. The unit is cubic meter. So we get the total as 10.42 cubic meter. Now we have to do the earthwork in filling for the trenches. We assume that the total filling for the trenches is 1/5 of the total volume of this excavation, that is 10.42 cubic meter. So we get 2.08 cubic meter. Now we have to do the earthwork in filling for the plinth. We can see here the internal dimension of the room is 3.6 meter from this point to this point, but we have to do the earthwork in filling from this point to this point. That means we have to reduce this small portion and this small portion. For this we need to calculate this length. So we have the width of the wall as 0.4 meter and above the superstructure we have the width of the wall, that is 0.3 meter. So this small portion is 0.4 minus 0.3 by half, that is 0.05 meter in this side and 0.05 meter in this side. Similarly, if we calculate 0.4 minus 0.3 by 2, we will get 0.05 again from this side and this side. So we need to reduce these two 0.05 in 3.6 meter to obtain this length. So we can write the length equals to this internal dimension of the room 3.6 meter minus this small portion 0.05 meter and this small portion 0.05 meter. So we will get the total length as 3.5 meter. So we can write the length equals to 3.5 meter. Similarly, internal dimension of the room 4 meter minus 0.05 from one side and another 0.05 from another side. So we will get 3.9 meter. We have to do the earthwork in foundation from this point to this point. That means this height is 80 centimeter. We assume that the soling is also 10 centimeter height and this LC is also 10 centimeter height. So we will get our height as 0.6 meter and we get the total quantity as 8.19 cubic meter. Now our next step is to calculate the cement concrete in foundation. Firstly, foundation trenches. We have two foundation trenches having the width of 0.7 and the lime concrete is only up to the height of 30 centimeter, that is 0.3 meter. So when we see this level in the plan, it will look like this. That means our width will become 0.7 and our height is 0.3 meter. Our center line is 16.4 meter and our width is 0.7 meter and the height of the foundation trench is 30 centimeter, that is 0.3 meter. So we get the total quantity as 3.44 cubic meter. Now we have to calculate the cement concrete in steps. So for this we need to see the section. In the section we have this portion as cement concrete, that is the length for the steps is 1.2 meter. We have the number of steps 1. In centerline method we always write this number as 1, but in long wall, short wall these can be different. We have the length of the steps 1.2 meter from the plan and the width is 0.9 meter from our section and the height of this cement concrete is 10 centimeter, that is 0.1 meter. So we get the total quantity 0.11 cubic meter. Our next step is to calculate the first class brickwork in foundation and plinth in the cement mortar, that is this portion, and this portion. And in 3D, the first class brickwork in foundation and plinth is this portion. So we have the number of the main walls 1, and the length is always centerline length because we don't have any partition walls. So our length is centerline length, that is 16.4 meter, and the width is 0.4 meter. So the total height is 0.6 meter plus 0.8 meter, that is 1.4 meter. And the total quantity is 9.18 cubic meter. Now our next step is to do the estimation for the steps. The length is always 1.2 meter for the step, that is this portion is 1.2 meter. And for the breadth, we can see that this lower portion is 0.9 meter and this upper portion is 0.3 meter. In such case, we can directly take the average of these two. Our width equals to 0.9 meter plus 0.3 meter divided by 2. That means the average of these two, that is 0.6 meter. And from this section we can see that the height of the riser is 0.2 meter. That means the height of the tree riser is 0.6 meter. So our total quantity is 0.43 cubic meter. Or if you are confused why we take this as average, we can also do this second process. So for this we have 3 steps, that is step 1. I'll take this as step number 2 and I'll take this as step number 3. Here we have numbers 1 and we can see that the length of this step is 1.2 meter. So I'll write as 1.2, and you can see that the breadth is this portion, that is 0.3 meter. So I can write 0.3 meter. And this step is only up to the 0.2 meter height. So I can easily write 0.2 meter. Again, I have this second step and it is also of length 1.2 meter. And this is of breadth same, that is 0.3 meter. And the height of this step is 0.2 meter plus this small portion is also 0.2 meter. That means 0.4 meter. Similarly, this third step is of length equals to 1.2 meter, 1.2 meter, and breadth is 0.3 meter, and the height is 0.2 plus 0.2 plus 0.2, that is 0.6 meter. So when we calculate all these quantities for these 3 steps, we get this quantity, and when we add all these 3 quantity, we will get same, that is 0.43 cubic meter. And our next step is to do the 2.5 centimeter thick DPC. Here we can see that the DPC is in 0.3 meter wall, that means in this portion and this portion, and in 3D we can see that this DPC is applied all over this building having 0.3 meter wall. So we have number of main walls 1, and we can easily write this as centerline length, that is 16.4 meter, and we have the width of the DPC 0.3 meter. We know that this 2.5 centimeter thickness is very negligible, so in DPC we don't write its height. So our total quantity is 4.92 meters square, but we don't consider the DPC in the doors, so we have to deduct this door portion. We have one number of door and its length is 1.2 meter and the width of the wall is 0.3 meter, so the total quantity will become 0.36 meters square, and we have to deduct this portion. That means 4.92 minus 0.36 is 4.56. Now we have to do the first class brickwork in cement mortar in superstructure, that means this portion in superstructure. And from this section we can see that the height of superstructure is 3.1 meter and the width of the wall is 30 centimeter, that is 0.3 meter. So the number is 1. We have the center line of the main wall, that is 16.4 meter, and the width of the wall is 0.3 meter, and the height of superstructure is 3.1 meter. So we get the total quantity 15.25, and the unit is cubic meter. Now we can see that there is also the parapet wall. So for this we need to calculate the center line of this parapet wall. From this section we can see that the width of this parapet wall is 20 centimeter and this is up to the height of 30 centimeter. To calculate this center line, firstly we need to calculate the outer to outer length of this parapet wall. That means this length is equal to this length, that is the inner length plus 2 times of this width of the wall. So firstly I will calculate the outer to outer length of this parapet wall. These two walls are of 30 centimeter, that means 2 times of 0.3, and then I will add this inner length, that means 3.6 meter. So we get this outer to outer length from this point to this point but actually we require the center to center line, that means this point to this point. So we have to reduce this small portion, that is 0.2 by 2, and this small portion, that is 0.2 by 2. So in this outer to outer wall, I will reduce minus 2 times of 0.2 by 2. We have calculated this center to center length only of this portion, but we have two parapet wall of this same size, so we can just write into 2 for all these. So I will multiply by 2. I have to calculate the center line from this center line to this center line. So our inner dimension of this room is 4 meter, and we have to add 2 times of this 0.3 meter wall to get this outer to outer length, and we have to subtract minus 0.2 by 2 and again minus 0.2 by 2 to get the center line of this portion. Or you can simply copy this and you can simply change the internal dimension as 4 meter. So I will get total length 16.8 meter. So the number of parapet wall is 1. I can easily write the center to center distance, that is 16.8 meter, and we have the parapet width 0.2 meter up to the height of 30 centimeter. So the width of the parapet wall is 0.2 meter and the height of the parapet wall is 0.3 meter. So I get the total quantity 1.01 cubic meter. While doing this first class brickwork in cement mortar in superstructure, we have not considered the doors. So we have to deduct those doors because in the door portion we do not have the first class brickwork. So we have the number of doors 1. The length of the door is 1.2 meter. The width of the door is 0.3 meter and the height of the door is 2.1 meter. So I get total quantity 0.76 cubic meter. We have not considered this RCC lintel portion. We have the bearing of 0.3 meter on both sides. That means from this portion to this portion, that is 0.3 meter. So we have to deduct all these portion. So we have one RC lintel. The door length is 1.2 meter, and considering these two bearing, we will get length equals to 1.2, that is door length plus bearing of 0.3 meter on both sides, that means into 2. So we will get 1.8 meter. So our length is 1.8 meter considering 30 centimeter lintel on both sides, and the width is 0.3 meter and the height of lintel is 0.15 meter from the section. So we get the total quantity as 0.08 cubic meter, and we have to deduct these two portions. So our total quantity is 15.42 cubic meter. So our next step is to do the RCC work excluding the reinforcement and shuttering. It means that we have to provide the reinforcement in this slab and in this lintel. So for this we need to calculate this total length and breadth of this slab portion. From this section we can see that this RCC slab is 30 centimeter from this wall, and same in this wall also. That means it has 30 centimeter projection. This is 30 centimeter projection on all sides. Here is also 30 centimeter projection, and here also 30 centimeter projection. If we calculate the outer to outer length of this wall, and if we add this 30 centimeter wall on both sides, we will get this full outer to outer portion of this RCC slab. So for this we need to calculate the outer to outer length. So our length is 4 meter plus 2 times of this 0.3 meter wall, and we have to add these two projections, that is 0.3 times of 2. So the length is 5.2 meter, length is 5.2 meter, and for the breadth I will calculate outer to outer length from this point to this point and add the two projections, that is 0.3 on both sides. We have the internal dimension of the room 3.6 meter and 2 times of this width of the wall plus 2 into 0.3 and 2 times of the projection, that is 2 times of the 0.3 wall. So the answer is 4.8 meter, and we have the height of this slab as 12 centimeter. So 0.12, and the total quantity is 2.99 cubic meter. And we have the numbers of lintel 1. The length of the lintel is this door length plus 2 times of its bearing, that is 0.3 meter. So length equals to 1.2 meter, that is length of the door, plus 2 times of 0.3 meter, that is 1.8 meter. And we have this width of the lintel as 0.3 meter. Height of the lintel is 15 centimeter from this section. So we get the total quantity as 0.08 cubic meter. Total quantity is 3.07 cubic meter. Now the next step is centering and shuttering. For this we need to understand what is centering and shuttering. The formwork which is used for horizontal structure members such as the beams, the slab, etc. is called centering. Here the framework is provided in the slab. So this is the horizontal member, so it is called the centering. But if the formworks are provided in the vertical member such as the column, then it is called the shuttering process. And we have already calculated this outer to outer length of roof, that is 5.2 meter and 4.8 meter. We can easily write the length as 5.2 meter and the width is same as this RCC work, that is 4.8 meter, and the total quantity is 24.96 meter square. Similarly, we have to provide the formwork in all these edges. On this edge, this edge, and this edge, that means all the 4 edges. So, and we have to provide the height of 0.12, that is the height of the slab. So we have already calculated this length as 5.2 meter and this length as 4.8 meter. So if we add this 5.2 plus 4.8 plus this 5.2 plus 4.8, then we will get this perimeter, and if we multiply by this height, we will get its total area. So the number of edges we can write 1, and the length is the total perimeter of this RCC slab. This length is 5.2 meter plus this length is 4.8 meter that we have already calculated. Again, this part is 5.2 meter plus 5.2, and again this portion is 4.8 meter. So we get the total area as 2.4 meters square. Now here is the lintel portion. We have to provide the formwork for this lintel portion also. So this is 1.8 meter lintel, and the height of this lintel is 0.15 meter, and width of this lintel is 0.3 meter. So we have to provide this formwork on this side and back side of this lintel, and we don't provide the formworks on the top. We always provide the formwork at the bottom of this lintel. So we have two sides of this lintel, that is this side and the back side of this lintel. So the numbers are 2, and the length of this shuttering is 1.8 meter, and we are considering this portion of the lintel, so we require this height, that is 0.15 meter. So our height is 0.15 meter and our total quantity is 0.54 meter square. Similarly, we have to provide the lintel at the bottom, that is from this portion to this portion, and the width of this lintel is 0.3 meter. We don't provide any formworks at the top. The lintel bottom is 1 in number, and its length is here up to this we have 1.2 meter, and this width of this lintel is 0.3 meter. So our total quantity is 0.36, and our total quantity is 28.26 meter square. And our next question is calculating this average lime terracing. From this section we can see that this lime terrace is kept just over this RCC slab. We have this inner to inner dimension of this room 3.6 meter, and we assume that this small portion is 0.1 meter and this projection is also 0.1 meter. So our length is 3.6 plus 0.1 plus 0.1. So length equals to 3.6 plus 2 times of 0.1, that is 3.8 meter. Similarly, we have the internal dimension 4 meter, and if we add 0.1 from this side and 0.1 from this side, then it will be its width. Breadth equals to 4 meter plus 2 times of 0.1, that is 4.2 meter. So length equals to 3.8, breadth equals to 4.2. The lime terrace is of very negligible thickness, that is 10 centimeters, so we neglect its height, and its total quantity is 15.96. Length is 3.8 meter. Breadth is 4.2 meter. We don't consider the height of lime terracing, and the total quantity is 15.96. Now next is solid work in door frame, and we have the solid of 10 centimeter into 8 centimeter, that is breadth into depth is given, and we can see here we have the frame here, and the door frame is in all the edges. Length of the door is 1.2 and the height of the door is 2.1. So we have 1.2 from this point to this point and this point to this point, that is 2 times of 1.2 and 2 times of this height, that is 2.1, because we have to calculate all this perimeter of this door. So length equals to 2 into 2.1, that is this height, plus this width is 1.2 meters, so 2 times of 1.2, so we will get 6.6 meter. So we have the length 6.6 meter, and the breadth is already given, that is 10 centimeter, 0.1 meter, and the height is 8 centimeter, that is 0.08. So the total quantity is 0.0528. So this is a steel grated door having the length of 1.2 meter and height of 2.1 meter. So the total quantity is 2.52 meter square. Now we have to do 12 mm thick cement plaster. Firstly, we have to do the cement plaster in this inner side of this room. That means we have inner dimension of this room 4 meter into 3.6 meter, and the height of this room is 3.1 meter. Here the height of this room is 3.1 meter. So we have to first calculate the perimeter of this inner side of this room and multiply by its height. Length equals to this 3.6 plus 4 plus 3.6 plus 4. So our length is 15.2 meter, and we have to do plaster along these sides, so we don't consider width, we have to consider its height. And we have the numbers 1, and our height is superstructure height, that is 3.1 meter. And our total quantity is 47.12, and the unit is meter square. While doing the plaster, we don't do the plaster below the ground level, we have to do plastering only above the ground level. So firstly we have to do plastering from this ground level up to this plinth level, and our height is 80 centimeter. We have to do plastering in this side from ground level to the plinth level, and this portion of the length is the outer to outer length of this room plus this small offset, that is 0.05, and we have already calculated this 0.05, that is this 40 centimeter wall minus 30 centimeter wall is 10 centimeter, and if we divide by 2 then we will get 5 centimeter on this side and 5 centimeter on this side. So this small projection is 5 centimeter on both sides. Our length is inner dimension of this room plus 30 centimeter wall on this side, 30 centimeter wall on this side, and 5 centimeter projection on this side and 5 centimeter projection on this side. So our length equals to, we can write 3.6 plus 2 times of 0.3 and this small projection of 0.05 on both sides. So plus 2 times of 0.05. But this is only one side. We have to do this plastering on all the sides of this house. That means this same length is considered twice. From this side also the length is same, so we can easily write into 2. This part and this part is remaining, so we have to calculate length of this side. That means the inner dimension of this room is 4 meter, and we have to add this 30 centimeter wall on both sides and this small projection of 0.05 on both sides. So we can simply write plus 4 meter room plus 2 times of the 0.3 wall plus 2 times of 0.05. And we can see that this length is also equal to this length, so we can easily write into 2. So our total length is 18 meter. We have 80 centimeter height from ground level to plinth level. In this case, we have to add 0.05 offset in the height considering the plaster of the projections. So the height is 0.8 plus 0.05 offset, that is 0.85 meter. So we get our total quantity 15.3. Now we have to do plaster from this plinth level up to the superstructure, excluding this RCC slab. That means from this portion to this portion, except this RCC slab. So we have to simply find out the perimeter of this house, that is outside perimeter of this house, and multiply by its height. So I can easily write this 3.6 inner dimension of this room plus wall dimension, that is 2 times of 0.3, and we have this wall from this side and also from this side, so I can simply multiply by 2, and again the 4 meter is inner dimension of this side and 2 times of 0.3 means the width of the wall, and I can simply multiply by 2 because I have the same length from this side as well as from this side. So our total length is 17.6. We have the height of superstructure 3.1 meter, and we have the height of this parapet 0.3 meter. So our total height is 3.1 meter plus 0.3 meter. So we can write the height equals to 3.4 meter, and the total quantity is 59.84. Now we have done plastering on all the outer sides of building, but we have to do the plastering on this inner side of this parapet. We have to do the plastering on this side, this side, this side, and on this side. So I have this inner dimension of this room 3.6 meter, and if I add these two walls I get 4.2 meter, but I need the inner dimension of this parapet from this point to this point, so I have to subtract these two 0.2 meter on both sides. So my length on one side is 4.2 minus 2 times of this 0.2. But this length is only of one side, that is from this portion to this portion, and we have this length 2 times, that means from this portion to this portion. So I can simply multiply by 2. Now we have to calculate the inner dimension of this parapet of this side and this side. So my length is inner dimension 4 meter room plus width of the wall is 2 times of 0.3 meter, and we have to subtract these two parapet walls, that means of 0.2 meter width, so minus 0.2 into 2. And this wall is considered twice, that means from this side as well as this side, so I can simply write into 2. So our total length is 16 meter, and we have the height of the parapet 30 centimeter. But in the inside portion there is also 10 centimeter lime terracing, so we don't need to plaster in this lime terracing portion. So our height is 30 centimeter minus 10 centimeter of lime terracing, so the height is 20 centimeter. Number of inside parapet wall 1. Total centerline length is 16. Height is 0.2. So the total quantity is 3.2. Now we have to do this plastering on the top of this parapet wall, that means on this side, this side, this side and this side. And here we have already calculated the centerline of parapet wall, that is 16.8. Centerline is 16.8, and when we multiply by its breadth we will get total area for the plastering. So number of top parapet wall 1. Length is center to center length, that is 16.8 meter, and we have to multiply by its breadth, that is the width of this parapet wall is 20 centimeter, so width equals to 0.2 meter. So our total quantity is 3.36 meter square. While doing this plastering work, we have not considered these steps as well as these doors. We know that we don't do plastering in this door portion, so we have number of doors 1, having the length of 1.2 meter, and the height of the door is 2.1 meter. So the total quantity is 2.52, and the unit is meter square. We have the length of this step 1.2 meter, and we consider this step up to the height of 0.8 meter, that is the individual riser has dimension of 20 centimeter. So this is 20 centimeter, again 20 centimeter, 20 centimeter, and this is 20 centimeter. That means we have to consider the height of 80 centimeter. So our height is 0.8 meter, and the quantity is 0.96. Now we are going to do the plaster for this step. Firstly, we have the risers of 0.2, and we are going to do plaster on these hatched areas. We have the length of this step as 1.2 meter, so length equals to 1.2 meter, and we have height of each riser 0.2 meter. That means 0.2 for this side, 0.2 for this side, 0.2 for this side, 0.2 for this side. That means total height equals to 0.8 meter, and our total quantity is 0.96. Now we have to do the plastering on this thread. That means we have 3 number of threads, so we can write the numbers as 3. We have the length of the thread 1.2 meter, and we have to multiply by this width. That means this is 0.3 meter, so our width is 0.3 meter, and we get the total quantity 1.08. Now we have to do the plastering on these sides of these steps. We have 2 sides from this side and 1 from another back side, so we have 2 number of these sides. We have to do plastering on these sides. We can see that this long side is 0.9 meter because each of these steps is of 0.3 meter. That means this total is 0.9 meter, and this small side is 0.3 meter. So if we have 2 different length, we can simply do average of these 2 lengths. So our length equals to 0.9 meter plus 0.3 meter by 2. So our length is 0.6 meter. We have to do plaster only up to this height. So the height is 0.2 meter plus 0.2 meter plus 0.2 meter, that is 0.6 meter. And our total quantity is 0.72. In this way, we have completed our full estimation of building.